The first blast echoed across the valley before the sun had cleared the jungle ridge. A moment later, the ground moved. Not trembled, not shifted. It moved. Slowly at first, then with a grinding certainty that seemed to come from deep inside the planet itself. Steam rolled through the morning mist. Iron cables groaned. Gears the size of wagon wheels. Then the shovel rose. 70 tons of steel lifted from the mud like a waking giant. Its long boom stretched outward over the raw wound cut into the hillside. Beneath it, hundreds of men scattered across the excavation floor, tiny figures beside the towering frame of riveted iron. The bucket hung open. 6 cubic yards of hardened steel teeth. When the operator pulled the lever, the machine lunged forward. The teeth struck the hillside with a sound that did not resemble digging. It sounded like something being torn apart. Clay fractured, rock splintered. The bucket filled in seconds, 13 tons of earth ripped from the slope in a single motion. The shovel swung slowly across the pit. Above the tracks waited a line of rail cars, each one already coated with layers of dried mud from the previous loads. The bucket opened. A waterfall of earth crashed into the wagons below. One swing. 13 tons moved. Another swing. 26. Hour after hour, the machine repeated the same motion. Bite, lift, swing, dump. Again and again, until entire hillsides vanished and the jungle slopes began to retreat. Men watched from the edge of the cut, their boots sinking into red clay, their clothes soaked with sweat despite the early hour. Some had arrived only weeks earlier from Barbados, Spain, Italy, or the American South. Many had never seen a machine like this. It did not look like a tool. It looked like something alive. A mechanical creature feeding on mountains. And here in the choking heat of Panama, that creature had been given a single command: cut a path through the continent. The shovel did not tire. Hour after hour it continued its slow mechanical rhythm. Steam hissed through its pipes. The massive boom lifted and lowered with deliberate precision. Steel cables tightened, strained, then relaxed as each load of earth rose from the canyon floor. Men wiped mud from their faces and stepped carefully along the narrow tracks that snaked through the excavation. Each rail line carried trains of dirt away from the cut, hauling the broken remains of hillsides toward distant dumping grounds. The process never truly stopped. When one train departed, another rolled forward to take its place beneath the waiting bucket. The machine worked with the patience of something that did not understand exhaustion. It only understood motion. Bite, lift, swing, dump. The numbers alone were difficult to comprehend. A single shovel could move nearly 300 cubic yards of earth in an hour. Across the canal zone, dozens of these machines operated simultaneously. Their combined effort removed mountains by the millions of tons. Yet every movement of the machine depended on a fragile chain of human decisions. A worker had to guide the train cars into position. Another had to signal when the bucket could swing. Mechanics crawled through the hot interior of the engines to maintain boilers and pistons that could fail without warning. Surveyors measured the slopes above the cut, searching for signs that the earth itself might collapse. One mistake could send steel crashing down upon the excavation floor, and the mountain was never truly stable. Each shovelful removed support from the surrounding hillsides. Clay softened in the tropical rains. Entire slopes shifted slowly under their own weight. Sometimes the ground held firm. Other times it moved without warning, burying tracks, machines, and men beneath thousands of tons of sliding earth. The shovel, powerful as it was, could not stop that. It could only dig. This was the paradox at the heart of the canal. Human engineers had created machines capable of reshaping geography itself, steel giants that could bite into hillsides and move the planet one bucket at a time. Yet those machines were surrounded by conditions that remained brutally indifferent to human control. The jungle bred disease. The climate destroyed equipment. The mountains refused to stay still. And every day, thousands of workers stepped into that environment, standing beneath machines that weighed more than their entire village back home. From a distance, the steam shovel looked invincible. Its steel frame towered over the excavation. Its bucket tore through clay and rock with mechanical certainty. It seemed capable of conquering the landscape itself. But the truth was more complicated. The machine was powerful, but the system around it was fragile. A stalled train could halt excavation for hours. A cracked boiler could silence an entire section of the cut. A landslide could erase weeks of progress in a single violent movement of earth. The canal was not being carved by machines alone. It was being carved by a delicate coordination between iron, steam, railroads, and human endurance. Every bucket of earth represented dozens of unseen actions, signals, calculations, maintenance, timing. If any piece of that chain broke, the machine became nothing more than silent metal stranded in the mud. Still, the digging continued, because the stakes extended far beyond the narrow trench in Panama. For centuries, ships traveling between the Atlantic and Pacific Oceans had been forced to sail around the southern tip of South America. The route around Cape Horn was one of the most dangerous passages in the world. Storms battered vessels with towering waves. Winds screamed across the open ocean with violent unpredictability. Thousands of sailors had died attempting the journey. A canal across Central America promised something extraordinary. A shortcut between oceans. A passage that could shorten global shipping routes by thousands of miles. But creating that passage required cutting directly through the spine of the continent, and the mountains standing in the way had no intention of cooperating. The steam shovel was the instrument chosen to fight that battle, a machine built not merely to dig soil, but to dismantle landscapes. It represented the belief that engineering, steel, and relentless labor could overcome the natural barriers that had defined geography for millions of years. Standing beside the roaring boiler of a working shovel, that belief felt almost convincing. The bucket would rise again, another train would carry the dirt away, the walls of the cut would grow deeper, but beneath the grinding machinery and the rising clouds of dust remained a quiet uncertainty. Could a machine truly defeat a mountain? Or would the mountain simply wait for the moment when gravity, rain, and shifting earth reclaimed everything humans had tried to carve from it? That question hung over every shift of every worker who stepped into the excavation. The machines promised progress, the landscape promised resistance. And between them stood thousands of men whose lives would determine which force ultimately prevailed. Long before the steam shovels arrived in Panama, the idea of cutting a passage between the Atlantic and Pacific Oceans had already haunted the ambitions of empires. The map itself seemed to invite the dream. At its narrowest point, the land bridge connecting North and South America stretched barely 50 miles from ocean to ocean. To the men studying global trade routes in the 19th century, that thin strip of jungle appeared almost absurdly small compared with the thousands of miles ships were forced to sail around the southern tip of South America. Yet geography is rarely measured only in distance. The obstacle was not width, it was terrain. The spine of Panama rose in a tangled chain of hills and ridges that trapped heavy tropical rain. Rivers flooded without warning. Soil shifted constantly. Beneath the jungle canopy lay layers of unstable clay mixed with volcanic rock that resisted excavation and collapsed unpredictably when disturbed. Even before a shovel touched the ground, the region carried another reputation: disease. Mosquitoes thrived in the humid lowlands. Yellow fever and malaria moved silently through camps and settlements, cutting down workers with terrifying speed. Entire construction crews could vanish within weeks. The jungle did not simply resist engineering, it attacked the people attempting it. Despite those dangers, the vision of a canal proved irresistible. In the late 19th century, a French engineer named Ferdinand de Lesseps believed he had already demonstrated that such a project was possible. Only a few years earlier, he had overseen the construction of the Suez Canal, a triumph that connected the Mediterranean Sea with the Red Sea and transformed global trade. The Suez Canal had been carved through flat desert terrain. Panama would be different. But de Lesseps believed the same strategy could succeed again. If a sea-level canal could cross the sands of Egypt, then perhaps it could also cross the jungles of Central America. In 1881, the French effort began. Thousands of workers arrived in Panama with picks, shovels, and early excavation machinery. Engineers mapped routes across the dense jungle. Camps and rail lines spread outward from the coast as construction crews pushed into the interior. For a moment, progress seemed possible. Then the land began to fight back. Heavy rains flooded the excavation zones. Slopes collapsed into newly dug trenches. The ground shifted so often that engineers struggled to maintain stable walls around the cut. Each landslide forced crews to dig out the same ground again and again, but the greatest enemy was invisible. Yellow fever swept through the camps. Workers developed sudden fevers, violent headaches, and bleeding that no doctor could explain. Entire work crews vanished within weeks. Hospitals filled with patients who rarely recovered. Malaria followed close behind. The disease did not kill as quickly as yellow fever, but it weakened workers so severely that thousands became incapable of continuing the labor. Men who had traveled halfway around the world to earn wages suddenly found themselves trapped in a hostile environment where survival itself became uncertain. The death toll climbed relentlessly. By some estimates, more than 20,000 workers died during the French attempt to build the canal, and the digging had barely begun. Meanwhile, the engineering challenges continued to grow. The French project relied heavily on manual labor and relatively small excavation equipment. Hillsides proved too massive to remove efficiently. Rail systems struggled to keep pace with the volume of earth that needed to be transported. The canal began to resemble an endless trench, slowly filling with mud and rainwater. Investors in France grew nervous. Costs soared far beyond the original estimates. Reports of disease and landslides circulated through European newspapers, eroding public confidence in the project. What had begun as a symbol of engineering triumph gradually transformed into a scandal. By 1889, the French Canal Company collapsed financially. Construction stopped. Machinery rusted in the tropical humidity. Excavation pits filled with water and vegetation. Rail lines twisted under the weight of landslides and neglect. The jungle began reclaiming everything. For years, the abandoned project stood as a monument to failure. Engineers across the world studied the disaster and reached a troubling conclusion. Perhaps the canal simply could not be built. The terrain was too unstable, the climate too hostile, the diseases too deadly. Even the most determined industrial power might find itself defeated by the combined forces of geography and biology. Yet the strategic importance of a canal through Central America did not disappear with the French collapse. If anything, the failure made the stakes even clearer. Ships traveling between New York and San Francisco still faced a journey of nearly 13,000 miles around Cape Horn. Storms destroyed vessels every year. Trade between the Atlantic and Pacific remained slow, expensive, and dangerous. Whoever could open a passage through Panama would reshape global commerce. By the end of the 19th century, a new industrial power began to consider whether the impossible task might still be attempted: the United States. American engineers studied the ruins of the French effort carefully. They examined the abandoned excavations, the collapsed rail lines, and the rusting machines left behind in the jungle. What they saw was not only failure, they saw unfinished work. The French had already removed millions of cubic yards of earth. Survey routes had been mapped. Portions of the canal corridor already existed beneath layers of mud and vegetation. The question was no longer whether the canal could be imagined. It was whether a nation with greater industrial power, larger machines, and a willingness to confront the jungle's dangers might succeed where others had fallen. If the project were attempted again, it would require something far more powerful than picks and shovels. It would require machines capable of dismantling mountains, machines strong enough to continue digging even when the earth itself tried to close the wound. And soon, those machines would arrive. At the beginning of the 20th century, the abandoned French canal zone looked less like an engineering project and more like a graveyard. Rusting locomotives sat half-buried beside overgrown rail lines. Excavation pits had become stagnant lakes surrounded by dense vegetation. The jungle had crept over machinery that once represented Europe's most ambitious industrial effort. But beneath the vines and mud lay something valuable: a partially opened corridor across the Isthmus of Panama. When American engineers and survey teams arrived to examine the ruins in the early 1900s, they understood immediately that the French failure had not erased the canal dream. It had only revealed how enormous the challenge truly was. The United States had recently emerged as a global industrial power. Its steel mills produced mountains of metal each year. Railroads stretched across the continent. New machinery, larger, stronger, and more reliable than anything available 2 decades earlier, had begun transforming American mining and construction. If the canal were attempted again, it would not be built with hand tools and fragile equipment. It would be built with machines. But before construction could begin, another obstacle had to be removed. Panama itself was still part of Colombia, and negotiations for canal rights had stalled. Political tensions dragged on for months, while diplomats argued over treaties and compensation. Then events moved quickly. In 1903, a revolution erupted in Panama. Within days, the region declared independence from Colombia. The United States recognized the new government almost immediately, and soon afterward, a treaty granted American engineers control over a strip of land across the isthmus. The Canal Zone was born. What followed was one of the largest industrial mobilizations the Western Hemisphere had ever seen. Ships carrying machinery began arriving at the Caribbean port of Colón. Crates of equipment filled the docks: boilers, steel beams, locomotives, rail cars, drilling equipment, and thousands of tons of mechanical parts. Engineers, doctors, surveyors, and administrators poured into the region. But the machines that drew the most attention were the new steam shovels. Unlike the smaller excavation tools used during the French attempt, these machines were enormous. Built by companies such as Bucyrus and Marion in the United States, they were designed specifically for large-scale earth-moving projects. Each one stood several stories tall. Steel tracks carried the machine across the excavation floor. A long boom extended outward, supporting a bucket reinforced with hardened teeth capable of biting into clay and rock. Inside the main housing, a powerful steam engine drove the gears and cables that controlled every movement. The machines were not elegant. They were brutal. A single shovel could remove more earth in one day than hundreds of laborers working with picks and shovels. When coordinated with trains waiting beneath the bucket, the process of excavation could continue almost without interruption. The system worked like an industrial assembly line. The shovel tore earth from the hillside. Rail cars carried the material away. Dump sites grew into artificial mountains of discarded soil. Then the trains returned for another load. Across the canal zone, dozens of these mechanical giants began working simultaneously. Their steel frames rose above the excavation sites like iron towers, their boilers venting constant clouds of steam into the tropical air. To many observers, the machines represented the true beginning of the canal project. The French effort had relied heavily on human labor struggling against an unforgiving environment. The American plan placed its faith in industrial power. If the land resisted, the machines would simply remove more of it. But technology alone could not guarantee success. The canal's most difficult section lay ahead, the narrow corridor known as the Culebra Cut. Here the route passed directly through the continental divide of Panama. Hills rose steeply on both sides of the excavation zone, composed of unstable layers of clay, sandstone, and volcanic rock. To create a passage deep enough for ships, engineers would need to remove tens of millions of cubic yards of earth. It was not a matter of digging a trench. It was a matter of dismantling a mountain. The steam shovels were the tools chosen for that task. Each machine represented an industrial wager that steel, steam, and relentless excavation could overcome a landscape that had defeated earlier attempts. Soon, the jungle valleys echoed with the sound of their engines. Rails were laid deeper into the cut. Trains began carrying soil away in endless lines of dirt-stained wagons. The slopes above the excavation slowly receded as the machines bit deeper into the hillside. From a distance, the operation resembled an army advancing against the earth itself, and at the front of that army stood the mechanical mountain shovels, machines built to tear open the continent one bucket at a time. But the deeper the excavation became, the more the engineers began to realize something troubling. The mountain was not simply waiting to be removed. It was moving. To understand how the Panama Canal was carved through the continental divide, one must understand the machine that did most of the cutting. The steam shovel was not a subtle device. It was an industrial predator built from riveted steel, driven by heat and pressure, and designed for one purpose alone: to move enormous quantities of earth as quickly as possible. But the Panama Canal demanded machines on an entirely different scale. A typical canal steam shovel weighed between 70 and 95 tons. Its main body rested on a set of steel tracks that allowed the entire machine to creep slowly across the excavation floor. Above the tracks sat the rotating house, a massive iron structure containing the engine, boiler, gears, and control systems. At the center of the machine burned a coal-fired boiler. Workers known as firemen shoveled coal into the furnace continuously, feeding the flames that heated water inside the steel pressure vessel. As the water boiled, steam pressure built rapidly, forcing energy into a network of pistons and cylinders. That pressure became motion. The engine turned a system of heavy gears connected to steel drums wrapped with thick cables. By tightening or releasing those cables, the operator could raise or lower the boom, extend the dipper handle, or open the bucket. From the outside, the movements looked simple. Inside the machine, dozens of components worked in careful coordination. The boom itself was a massive triangular frame of steel beams, projecting outward from the front of the shovel. Suspended from its tip hung the dipper handle, a long arm that pushed the bucket forward into the hillside. The bucket was the machine's true weapon. Constructed from hardened steel plates, it resembled a giant scoop reinforced with jagged teeth along its cutting edge. Those teeth were designed to bite into compacted clay and fractured rock, tearing material loose as the dipper handle forced the bucket forward. When the bucket filled, the operator pulled a lever that raised the boom while simultaneously tightening the hoisting cable. The entire load, often 5 to 6 cubic yards of earth weighing more than 10 tons, rose into the air. Then the machine rotated. The rotating house turned slowly on its central bearing, swinging the loaded bucket toward a line of waiting rail cars positioned along tracks beside the excavation. At the precise moment the bucket reached its target, another lever released the bottom door. The earth fell. Clay, rock, and broken soil poured into the rail cars below with a thunderous crash. Within seconds, the bucket closed again, ready for another cycle. A skilled operator could complete this entire sequence in less than a minute. Over the course of an hour, the machine might repeat the process dozens of times, removing hundreds of cubic yards of material from the cut. But the steam shovel never worked alone. Its true power emerged only when integrated into a larger excavation system. Railroad tracks crisscrossed the canal zone like arteries feeding the dig sites. Trains waited beside each shovel, carrying freshly excavated soil to distant dumping areas where the material formed vast artificial embankments. As soon as one train filled, it pulled away. Another train rolled forward. This constant movement ensured the shovel never remained idle for long. The machine dug, the trains carried, the dump sites grew higher and wider across the landscape. At peak operation, the canal workforce operated more than 70 steam shovels simultaneously. Each machine represented a concentrated source of industrial force. Combined, they removed earth on a scale rarely attempted in human history. Millions of cubic yards disappeared month after month as the cut deepened across the continental divide. Standing near one of these machines while it worked was an overwhelming experience. The ground trembled beneath the steel tracks. Steam vented from valves with sharp bursts of pressure. The clatter of gears echoed across the excavation as cables tightened and released, and always there was the sound of the bucket, the teeth striking the hillside, the scrape of steel against stone, the sudden roar of falling earth. For the engineers directing the canal project, the steam shovel symbolized the triumph of industrial design. It turned a nearly impossible excavation into a repeatable mechanical process. Dig, load, haul, repeat. But the deeper the shovels cut into the mountains, the more unstable the surrounding slopes became. Every bucket of earth removed from the hillside altered the balance of the terrain. Rainwater seeped into exposed layers of clay. The weight of the upper slopes pressed downward against newly carved walls, and slowly, almost imperceptibly at first, the mountain began to shift. The machines were powerful enough to tear the earth apart. What they could not do was prevent the earth from fighting back. At first, the movement was subtle. Surveyors stationed along the edges of the Culebra Cut began noticing that their measuring markers had shifted slightly between inspections. Stakes hammered firmly into the ground appeared a few inches out of alignment. Rail tracks that had been laid perfectly straight developed faint curves that had not existed the week before. No explosion had occurred. No storm had swept through the valley. The mountain was simply moving. The soil in the central spine of Panama was unlike the rock formations encountered in many mining operations. Instead of solid granite or limestone, much of the terrain consisted of layered clay, sandstone, and fractured volcanic material. When dry, these layers could hold their shape. When wet, they behaved differently. Heavy tropical rains saturated the exposed slopes of the excavation. Water seeped deep into the clay, turning it into a dense, slippery mass capable of sliding under enormous pressure. The deeper the engineers cut into the hillsides, the less support remained beneath the upper layers of soil. Gravity began to do the rest. Entire sections of the mountain started creeping slowly toward the canal trench. At first, The motion measured only inches per day. Workers noticed cracks forming across the surface of the slopes above the excavation. Trees leaned at strange angles as the ground beneath their roots shifted. Then the slides accelerated. One afternoon, a section of hillside, several hundred feet wide, suddenly collapsed into the canal cut. Thousands of tons of earth surged downward like a slow brown avalanche, burying rail lines and filling the freshly excavated trench with mud and debris. The steam shovels that had carved the channel were forced to turn around and begin digging again. What had taken weeks to remove returned in a single afternoon. Engineers soon realized that the landslides were not isolated accidents. They were structural consequences of the excavation itself. Each time the shovels removed another layer of soil, the stability of the surrounding slopes weakened further. Rainwater increased the pressure within the clay. The mountain responded by sliding toward the lowest point, the canal trench. It was an engineering problem with no easy solution. Reinforcing the slopes with retaining walls was impossible at such enormous scale. The only practical response was to continue digging, removing the collapsed material again and again until the slopes eventually settled into a stable angle. But that meant the excavation would never truly stay finished. Every landslide erased weeks of work, sometimes months. The worst slides occurred in the narrowest section of the canal route, where the excavation passed directly through the Continental Divide. This area became known as the Culebra Cut, and it quickly developed a reputation among workers and engineers alike. It was the place where the mountain fought hardest. During the rainy season, entire slopes could move overnight. Railway tracks twisted under the pressure of shifting soil. Shovels that had been carefully positioned beside the excavation sometimes found themselves partially buried beneath fresh layers of earth. One slide near the town of Cucaracha displaced so much material that engineers estimated more than 2 million cubic yards had collapsed into the canal trench. For weeks, the excavation became a massive recovery effort. Shovels dug out buried rail cars. Crews cleared tracks that had disappeared beneath thick layers of clay. Trains carried endless loads of mud away from the cut, while surveyors tried to determine whether the surrounding slopes might collapse again. Often they did. The workers began to understand that the machines they relied upon were not conquering the mountain. They were fighting it. Each day, the steam shovels advanced the excavation a few feet deeper. Each night, gravity and rainfall threatened to undo the progress. The canal project had become a slow contest between engineering persistence and geological reality, and the mountain had time on its side. The machines could dig quickly, but they could not stop the forces acting on the landscape itself. Rain would continue falling. Clay would continue softening. Slopes would continue shifting toward the empty trench carved through their center. The deeper the canal became, the more unstable the terrain above it grew. This was the hidden flaw in the project. The machine that could move mountains had accidentally created a mountain that would not stay still. No explosion had occurred. Every morning before the steam whistles signaled the start of excavation, thousands of men moved toward the cut. They came down narrow dirt roads and along temporary rail lines that threaded through the canal zone. Some carried tools. Others carried only their lunch tins and water flasks. Most wore clothing already stained with layers of clay that never seemed to wash away. The machines dominated the landscape. Steam shovels stood along the edges of the excavation like towering iron animals, their long booms reaching out over the trench. Boilers hissed in the humid air, while firemen fed coal into the furnaces that powered the engines. But the machines did not operate themselves. Each shovel required an entire crew. Inside the cab sat the operator, controlling the movement of the boom and bucket through a set of heavy levers connected to gears and cables. Beside him worked the crane man and the swing engineer, coordinating the machine's motion as it lifted and rotated massive loads of earth. Below them, signalmen directed trains into position beneath the bucket. Track crews maintained the constantly shifting rail lines. Mechanics crawled through the machinery performing repairs on engines that operated under extreme heat and pressure. Around them moved thousands of laborers. Many had traveled to Panama from Caribbean islands such as Barbados, Jamaica, and Trinidad. Others arrived from Spain, Italy, and the American South. Recruiters promised steady wages and steady work, drawing men who hoped to support families thousands of miles away. The canal project quickly became one of the most diverse industrial workforces in the world, but it was also deeply divided. The administration of the canal zone organized workers into a rigid system known as the gold roll and the silver roll. Skilled American and European employees, engineers, supervisors, and machine operators were paid in gold-backed currency and received better housing and facilities. Most laborers from the Caribbean were placed on the silver roll. Their wages were lower. Their housing was crowded wooden barracks often built close to the excavation sites. Mosquitoes swarmed through open windows during the night, and the humid heat rarely allowed restful sleep. Despite those hardships, the work continued. A typical shift beside a steam shovel could last 10 hours or more. Workers stood on unstable ground only yards away from machines weighing nearly 100 tons. The constant noise of engines and falling earth filled the air, making communication difficult without hand signals or whistles. Every movement of the machine carried danger. The bucket swung overhead, carrying loads of clay heavy enough to crush a man instantly if the cable failed. Rail cars rolled in and out beneath the shovel, sometimes only feet from workers standing along the tracks. Boilers operated under intense pressure, and a mechanical failure could release scalding steam without warning. Then there were the landslides. Crews working in the Culebra Cut knew the mountain above them was unstable. Cracks appeared in the slopes without notice. Rocks tumbled down the excavation walls. Sometimes the first sign of danger was a low, rumbling sound, followed by an entire section of hillside collapsing into the trench. When that happened, survival depended on speed. Workers dropped tools and ran for the edges of the excavation while the sliding earth buried tracks and machinery below. Some machines managed to escape by crawling forward along their rails. Others disappeared beneath tons of mud before their crews could react. Yet even after these disasters, the labor returned the next day. For many men, the canal represented opportunity despite the risks. Wages earned in Panama could support families in distant countries where work was scarce. Letters traveled across oceans, carrying money and stories of the enormous machines tearing through the jungle hills. The steam shovels became symbols of that effort. From a distance, the machines appeared unstoppable. Their buckets carved enormous bites from the mountainside, loading trains that carried away the broken earth. The progress seemed visible day by day as the canal trench grew deeper and wider. But beneath the iron towers stood the workers who made the machines function. They fueled the boilers. They maintained the rails. They stood within reach of the bucket as it swung overhead. And they knew that every shovelful removed from the hillside might loosen the ground above them. The canal was not being carved by machines alone. It was being carved by men willing to stand beneath those machines while the mountain slowly shifted around them. By 1907, the excavation at the Culebra Cut had reached depths few engineers had imagined possible only a few years earlier. The canal trench sliced directly through the continental divide, its walls rising steeply on both sides like the edges of a colossal canyon. Rail lines threaded along the floor of the cut, carrying endless trains of excavated soil toward distant dumping grounds. Above them, the mountains loomed, and they were beginning to collapse. The first major slides had already forced engineers to rethink the entire strategy of excavation. Each time the steam shovels removed another layer of earth, the pressure within the surrounding slopes increased. Clay softened under tropical rain, and gravity pulled the upper layers downward toward the open trench. At first, the slide seemed manageable. A hillside would slump slowly into the canal cut, covering sections of track and partially burying machinery. Crews responded by digging out the debris and rebuilding the rail lines. Work paused briefly, then resumed. But the deeper the excavation grew, the more violent the slides became. Entire ridges began to shift. One afternoon, a massive section of hillside along the eastern wall of the cut began to crack apart. Workers noticed trees leaning at unnatural angles and rails bending under the pressure of moving soil. Surveyors warned that the ground above the trench was no longer stable. Then the mountain gave way. Thousands of tons of earth surged downward in a slow but unstoppable wave. Clay, rock, and broken vegetation poured into the canal trench, burying rail lines and filling weeks of excavation work in a matter of minutes. Steam shovels scattered across the floor of the cut found themselves surrounded by sliding earth. Some operators managed to escape by driving their machines forward along the rails, clawing through the debris as the ground behind them collapsed. Others were not so fortunate. One shovel disappeared beneath the advancing wall of mud, its boom the last visible part before the landslide swallowed it entirely. For days, the canal zone resembled a battlefield. The excavation had not been destroyed, but it had been buried. Engineers ordered every available machine into the cut. Steam shovels that had been working on distant sections of the canal were moved to the site of the collapse. Trains arrived in long lines, ready to haul away the enormous mass of earth that now filled the trench. The machines began digging again. Bucket after bucket lifted the fallen mountain from the canal floor. Rail cars carried the debris away, only for fresh slides to send more earth crashing down from above. The workers soon realized they were no longer simply excavating the canal. They were fighting the landscape itself. Each time the machines cleared the trench, the surrounding slopes crept closer to collapse. Rain soaked the unstable clay. Cracks spread across the hillsides like fractures in glass. Sometimes the slides began slowly, allowing workers to escape. Other times they arrived without warning. A rumbling sound would echo across the cut, followed by the sudden movement of thousands of tons of soil racing toward the excavation floor. Crews dropped tools and ran while the machines struggled to escape along their narrow rail paths. The war against the mountain had become relentless, yet despite the repeated collapses, the engineers refused to abandon the project. Instead, they adapted. Rail tracks were redesigned so they could be moved quickly when slides buried sections of the excavation. Additional steam shovels were assigned specifically to clearing landslides rather than advancing the canal itself. Drainage channels were cut along the slopes to carry rainwater away from the unstable clay. The canal became a living system of machinery, constantly adjusting to the unpredictable behavior of the terrain. And slowly, through persistence rather than victory, the machines began to gain ground. The shovels dug deeper. The trains carried away millions of cubic yards of debris. The unstable slopes continued to slide, but the excavation always resumed afterward. It was no longer a question of preventing landslides, it was a question of surviving them. Day after day, the mechanical mountain shovels returned to the trench, tearing away the earth that had tried to reclaim it. The mountain resisted. The machines continued, and the canal cut grew wider with every passing month. By the time the worst landslides of the Culebra Cut had been cleared, the canal project had already removed more earth than many engineers believed possible. But the mountain had forced the project to change. The early vision of excavation had imagined a straightforward industrial operation, machines carving a trench, trains carrying the debris away, and engineers guiding the process toward completion. The reality proved far more complicated. The canal could not simply be dug, it had to be constantly rebuilt. Each landslide altered the shape of the excavation. Slopes that had once been carefully measured were forced outward as unstable soil continued to creep toward the canal floor. Engineers realized that the only way to prevent constant collapses was to widen the cut, reducing the angle of the surrounding hillsides until gravity could no longer pull them downward. This meant removing even more of the mountain. Steam shovels that had originally been assigned to deepening the canal were now ordered to carve away the upper slopes as well. Entire ridges disappeared under the repeated bite of steel buckets. The excavation widened year after year, transforming the narrow trench into a vast canyon stretching through the center of Panama. Rail systems expanded alongside the growing cut. New tracks were laid constantly as excavation advanced across the shifting terrain. Trains operated day and night, carrying away millions of cubic yards of clay, rock, and fractured soil. The dumping grounds grew into enormous artificial hills scattered across the canal zone. One of the largest of these dumping areas would later become the foundation for the Pacific entrance of the canal itself. By 1913, the numbers had reached staggering proportions. More than 200 million cubic yards of earth had been removed from the canal route since construction began under American control. A large portion of that excavation came directly from the Culebra Cut, where the steam shovels fought the unstable mountains for nearly a decade. At peak operation, the canal zone functioned like a vast industrial organism. Steam shovels dug continuously along the excavation. Locomotives hauled trains of dirt away from the cut. Repair crews maintained the machinery that never seemed to stop moving. Surveyors recalculated slopes and drainage channels after every major slide. Thousands of workers moved through the system each day, feeding the boilers, laying track, and clearing the debris left behind by the mountain's resistance. Slowly, the landscape began to change. The steep ridges that had once divided the isthmus gave way to a broad channel stretching from horizon to horizon. Where dense jungle had once covered the hills, bare slopes of clay and rock now descended toward the canal floor. The machines had not merely carved a passage through the continent, they had reshaped the continent itself. Yet even as the excavation approached completion, the memory of the landslides remained fresh in the minds of the engineers directing the project. They understood that the canal was not a permanent victory over the landscape. It was a carefully managed balance between engineering and geology. Drainage systems were expanded to carry rainwater away from the slopes. Monitoring teams watched for signs of ground movement along the canal walls. Excavation continued even after the main trench had been completed, removing unstable material before it could slide into the channel. The machines that had built the canal were now tasked with protecting it, because the mountain, though defeated in one sense, had not disappeared. It still surrounded the canal on every side, and gravity never stopped working. In August 1914, the canal finally opened. Ships began passing through the channel carved by steam, steel, and relentless excavation. A journey that once required nearly 13,000 miles around Cape Horn could now be shortened by thousands of miles through a narrow passage across Panama. Global trade shifted almost immediately, but beneath the calm water of the canal lay the scars of the excavation, the canyon cut by steam shovels, the hills carried away by trains, and the labor of thousands who stood beneath the machines. The mechanical mountain shovels had done what once seemed impossible. They had torn open the earth, and through that wound the oceans met.